Hey everyone, this lesson is 2-2 proportional reasoning. These problems can be found on page 97 through 99 in your Algebra 2 textbook. All right, so let's get started. Today's lesson, we're going to talk about a ratio, and a ratio is a comparison of two numbers by a division. A proportion is an equation stating that two ratios are equal. In a proportion, the cross products are equal. If a proportion contains a variable, you can cross multiply to solve for the variable. When you set the cross products equal, you create a linear equation that you can solve by using the skills that you learned in lesson 2-1. Just a reminder of what you already know, 8/4 is equal to 1/2. And what we talk about when we say cross products, we're crossing 4 times 2, product is multiplication, is equal to 8 times 1. And you can see that that is true. Again, 2/3 is equal to 6/9, so let's do the cross products. Product, again, is multiplication, is equal to 3 times 6. So 18 is equal to 18. All right, so let's move on a little bit. So what we're going to do in the first one is the same exact thing, except this time we have a variable x. So we're going to say 9x is equal to 22 times 13.5. All right, so 22 times 13.5 is equal to 297, and that is going to be 9x. So when we look at our x, remember we want x to equal some number, and right now x is multiplied by 9, so we want to get rid of that 9, so we're going to divide both sides by 9. It's going to leave me with x equals 33. Okay, doing the same thing on the second problem, 512 times w is equal to 16 times 64. And 16 times 64 is 1024 equals 512w. Again, we want w to be by itself, so we're going to divide 512 by both sides. So that's going to leave w equals 2. All right, that's pretty simple. So why don't you go ahead and put your video on pause for a minute and just try these two by yourself, and then turn it back on and you can check your answers. All right, so y times 84, 84y equals 12 times 77. All right, and 12 times 77 is 924 equals 84y. We want y to be by itself, so let's divide 84 on both sides. And we do that, y is equal to 11. Okay, let's do the next one, 8x times 2.5 is equal to 15 times 7. 15 times 7 is 105 equals 2.5x. Again, 2.5 is multiplied by our x and we want to get rid of it, so let's divide 2.5 by both sides. This equals 1, so we have x equals 42. Okay, moving on. We can also use ratios and proportions to help us with solving percent problems. This problem says a college brochure states that 11.5% of the students attending the college are majoring in engineering. If 2,400 are attending the college, how many are majoring in engineering? So when we use proportions with percent, we are generally talking about parts and wholes, the part and the whole. And our question says that we have 11.5%. So that's our part. And our whole is 100%. All right. And it tells us that there are 2,400 are attending the college. So that's our whole, the whole number of students attending our college. And it asks how many are majoring in engineering. So we're going to let that be X. Now we can set this up doing our cross products. We say 100X is equal to 11.5 times 2,400. Okay, so when we multiply 11.5 times 200, we get 27,600, and that equals 100x. So now we'll just divide 100 by both sides, and so we get x equals 276. So 276 students are engineering students. Another way we could do this is just write it out as an equation, a percent equation, and it says 11.5% of the total is, which would be equal, 2,400. All right. Oops, I said that wrong. Of the total is the engineering students. Engineers. All right, so let's see what we can know here. We know 11.5% is the same as 0.115. Of means times. The total students is 2,400, and that will give us X. And when you multiply 0.115 times 2,400, again, we get 276 equals X. So there's 276 engineering students. All right, why don't you try one on your own. At Clay High School, 434 students, or 35% of the students, play a sport. How many students does Clay High have? So go ahead and try that on your own real fast. Okay, so let's do this. Remember, we talked about percentages being parts and wholes. So we're going to say part over the whole. And the question tells us that we have 35% of the students. So our part is 35 and our whole is 100%. Now let's look at the question. It says, how many students does Clay High have? So that's going to be our whole. And we don't know, so we're going to call that X. We do know that 35% of the students represents 434 students. All right, so now that we have our proportion set up, we can just do our cross multiplication. 35x is equal to 4,400. Let's do it like that. 43,400. All right, so we're going to divide both sides by 35 so we can get x by itself. And so once we do that, we will come up with the answer of 1,240. All right. Okay, let's move on. A rate is a ratio that involves two different units. You are familiar with many rates, such as miles per hour, words per minute, or dollars per gallons of gas. So let's do an example one. This is a kind of a tricky one, so let's go through it together. A pedometer measures how far a jogger has run. To set her pedometer, Rita must know her stride length. Rita counts 328 strides as she runs once around a 400-meter track. A meter is about 39.37 inches. How long is her stride in inches? All right, so we're working with a lot of different things. We've got meters and strides and inches. So let's just go slow on this. Let's start out with what we know, and we're going to have meters and we're going to have strides. Okay, so we know that she ran 400-meter track. So we're going to put 400-meter track up here. And we also know that she had 328 strides in that same time. 328 strides. Okay. Now, we also want to know, the question says, she wants to know her stride, let's see, how long is her stride in inches? Okay, so we know we want to know one stride, but we're in meters right now, so we're just going to say how many meters is one stride. So we're going to say x meters. All right, so now we can set up an equation, 328 times x. 328x is equal to 400 times 1, which is 400. All right, so what we want to do at this point, we see that 328 is multiplied to our x, so let's divide everything by 328. And that leaves us, when we divide, it's going to say x equals approximately. Now, not exactly, but approximately. So I'll put the squiggly equal sign, 1.22. 1.22. Okay, so now I know that her stride is 1.22 meters. All right, but we also need to change that to inches. All right, and what we know is that 1 meter is equal to 39.37 inches, and we know that 39.37 inches is equal to 1 meter. Now your book calls it the conversion factor. This is a conversion factor. They're both equal to the same thing. I called it a unit multiplier. Either one is fine. So let's see if we can figure out what we know so far. We know that 1.22 meters is the same as one of her strides. All right, and we're going to multiply by one of these two, and we want it to end up in inches, so let's choose this one right here. So we're going to say 39.37 inches is equal to 1 meter. So our meters cross out, and when we multiply 1.22 times 39.37, we get approximately 48 inches for one stride length. So here's your answer. Okay. It's a little bit tricky, so go ahead and try the next one on your own. Turn the video off for a minute and see if you can answer the next one. It says Luis ran the same 400-meter track in 297 strides. Find his stride length in inches. Okay, so give it a try. Turn the video on pause and then come back on when you're ready. Okay, so once again, we have meters and strides. And once again, we know that he went 400 meters per, and he had, though, 297 strides. All right, and we want to know how many meters is one stride. So we're going to say x meters is equal to 1 stride. All right, now we can set up our equation again. So we say 297 times x is equal to 400 times 1, equals to 400. All right, and 297 is multiplied by our x, but we want our x to be by itself. So let's divide 297 on both sides. So when we do that, we find out that x is approximately 1.35 meters. Okay, so what that tells us is that 1.35 meters is equal to 1 of his strides. And we want to use our unit multiplier, or conversion factor, which is 37 is the same as 1 meter, and 1 meter is the same as 39.37 inches. And we want our answer to be in inches, so we're going to choose this one so we can cross out our meters. So let's say times 39.37 inches over 1 meter. So when we multiply these, we can say 1.35, our meters cross out with meters, and 1.35 times 39.37 is approximately 53 inches, and then the strides come on over per 1 stride. All right, there you go. So there's your answer. All right, let's talk about similar figures. Similar figures have the same shape, but not necessarily the same size. Two figures are similar if their corresponding angles are congruent and corresponding sides are proportional. So let's look at a problem like this. It says ABC has vertices 0, 0. So this is A. And B is 8, 4. 1, 2, 3, 4. So this is B. And C has 8, 0. So this is C. Okay. So it says, let's go ahead and draw our triangle in. Let's see if I can get something relatively straight. There we go. So here is ABC triangle. And now we have ADE, which is similar to ABC. So that means they're going to be proportional. Okay, it says it has a vertex at E, which is 2, 0. So here's 2, 0. So this is E. All right. And so the question says to graph ABC and ADE on the same grid. So here we have ABC, and we also have A and E. So we can see that D is going to be right here. You can already see what this is going to look like, but let's do the proportions just to prove it out. So we can see that AC is 8, so AC is 8, and AE is 2. All right, we know that BC is 4, and this one we don't really know for sure, but we can see it, so 4 to 1. Or we'll just say X because we don't really know it yet. So now we can use our proportions. 2 times 4 is 8 is equal to 8x. All right, so we want our 8 to go away. So we're going to divide both sides by 8. So 1 is equal to x. And here you can actually visually see that 1 is equal to x. Okay, let's try another one. Once you try this one on your own, you may need some graph paper. Go ahead and put your video on pause. Try and solve this one on your own. Okay, here we go. So it says, goodness, we're going to just go this way. Let's see. Let's see. 0, 0. We're going to go like this. 0, -1, -2, -3, -4, -5, -6. And this is going to be 0, 1, 2, 3, 4, 5, 6. Okay. So D is 0, 0. D. E is -6, 0. E. And F is 0, -4. So it's going to be down here. All right, so here is our triangle. And it's similar with DEF, and it has a vertex G of -3, 0. So -3, 0. There we go. And we want to graph DEF and DGH. Okay, so we can see that this one is going to be proportional to this one. So let's do our proportions here. E to D is 6. We don't have to worry about our negatives on this one because we're just counting units. So E to D is 6. So 6 is to 1, 2, 3, this small proportion, as this big one, which is 4, is to X. We don't know what that's going to be. So we can say 3 times 4 is equal to 6 times X. So 6X is equal to 12. So we're going to divide both sides by 6. So X is equal to 2. There we go. Okay, moving right along. Indirect measurement uses known lengths, similar figures, and proportions to measure objects that cannot easily be measured. All right. So, a rock climber wants to know the height of a cliff. The climber measures the shadow of her friend, who is 5 feet tall and standing beside the cliff, and measures the shadow of the cliff. If the friend's shadow is 4 feet long and the cliff shadow is 60 feet long, how tall is the cliff? So what we're supposed to do is sketch the situation, and then the triangles formed by using the shadows are similar, so the rock climber can use a proportion to find h, the height of the cliff. Okay, so let's just draw our friend is 5 feet tall, and so we're going to call that 5 feet, and his shadow is 4 feet long, 4 feet. Okay, so here's a triangle, and now he also knows that the cliff shadow is 60 feet long. So let's draw 60 feet here. And he wants to know how tall the cliff is. So we're going to call that X. So we can use a proportion on this and say the small shadow to the large shadow. 4 is to 60, as 5 is to X. Okay, so we could just do the long shadow to the short shadow to the long shadow is the same as 5 is to X. And notice that we kept them in order. We kept the ones on top, which is the smaller triangle, and the ones on the bottom are the larger triangle. Now we can just set up our proportion. 4 times X, 4X is equal to 60 times 5. 60 times 5 is 300. So 4x equals 300. Divide both sides by 4. So that gives us 8x is 75. And they actually said we should solve for h, which is the same thing. So the height is going to equal 75 feet. Okay, and one more for you to try on your own. A 6-foot tall climber casts a 20-foot long shadow at the same time that a tree casts a 90-foot long shadow. How tall is the tree? So go ahead and put your video on pause and try and solve this, and then turn it off of pause, and we'll come back and we'll solve this one together. Okay, let's see how we do it. Okay, a 6-foot tall climber, 6-foot tall climber, let's see here, 6-foot tall climber cast a 20-foot long shadow. Okay. At the same time that a tree, you're going to assume a tree is bigger than 6 foot, casts a 90-foot shadow. How tall is the tree? So we're going to call that X for our tree. And now we're going to do the small triangle is proportionate to the larger triangle. And so let's use our 6 foot is to X. 6 foot is to X, as 20 feet is to 90. Okay, so now we can use our proportions. X times 20 is 20x equals 6 times 90. 6 times 90 is 540 equals 20x. Divide both sides by 20, so we get x by itself. And your answer is x equals 27. There you go. So the height of the tree is 27 feet tall. Go ahead and put our feet in there. Okay, so we have made it to the end of this lesson. I hope that you learned a lot, and we will talk more about these in class next time we meet. Have a great day. Bye.